C, and D, we're asked to find the distance between A and B first. So I might just join those up first. I'm going to just take out my ruler and I want to join up A and B. So I'm creating a line segment here, A and B. So the first question is asking us to work out that distance there. To work out that distance, I think the easiest way, rather than using the formula, would be to create this little right angle triangle and mark off the other sides in it. So in this triangle, I'm going to use Pythagoras' theorem. The distance between 3 jumping out to 8 is a jump of 5. And from 2 jumping up to 5 is a jump of 3. Therefore, the hypotenuse on this side, or sorry, excuse me, I'm using the wrong language there. 5 squared is 25. 3 squared is 9. And the square on the hypotenuse is 25 plus 9, which is 34. So the distance between A and B is going to be the square root of 34. Now I would always take out my calculator just to see, does that neaten up a little bit? And the square root of 34, it doesn't. The neatest way of calling it is the square root of 34. As a decimal, it's roughly 5.8, but the most accurate way of writing it is the square root of 34. So the first answer, the size of AB using Pythagoras' theorem, is the square root of 34. Did anyone get that answer?
Yeah.
Okay.
Yeah.
I'm going to use the same method. It's okay, just quickly, and I'm going to have to scribble out just to keep my picture neat, I suppose, each time. Or maybe will I redraw it? No, I draw little triangles for this. I might draw it on the page actually. So I'm going to draw a little sketch. This might be another way to do it. So the next question is asking me for the size of AC. I can see roughly where A and C are looking at this. So if I call A here, C here, so I'm doing this a little rough sketch. Okay, so this is not exactly, but it's going to be good enough for me to just be able to draw in the sides and use Pythagoras' theorem on it. As I go from A to C, I see the distance going from 2 to 3, and the x is a distance of 1. And as I jump up from -2 up as far as 5, it's a jump of 7. So 1 squared is 1, 7 squared is 49. The square on the hypotenuse is going to be 49 and 1, which is 50. So AC is going to be the square root of 50. Now again, if I type that into the calculator, square root of 50, it tells me 2 root 5. So this is the square root of 50 if you want. So the answer to the question, to this question, is AC is equal to the square root of 50, which is equal to 2 root we have. Oh, okay. So I suppose the main idea, if I was to draw a line here, okay, and so imagine that this on an axis is kind of going 1 for 1. So I'm just going to go draw a line that goes through some reasonable looking points here. Okay, so I'm drawing a line here. And I was to work out what's the slope of this line, how is it changing? Okay, it seems to be going through a nice point here and a nice point here. How is this line changing? Well, it seems to be changing in a way that when I increase a certain amount this way, it seems to rise up a certain amount this way. Now, on your x and y axis, I'm just going to draw those roughly here. So for the xy axis, this here is the positive direction of the y-axis, and this here is the positive direction of the x-axis. So it seems in this case that when the x value, as you climb up or move from point A to point B along this line segment shown here, it seems that the way I've drawn it, x is increasing by 1, 2, 3, 4. I think I'm counting 10. And the y value, the rise, seems to be increasing also by 3. So firstly, a comment on the slope of this. The slope of this is positive. And the reason it's positive is because both are increasing. As x increases, y also increases. So this is a positive slope. Just to comment on that. The slope is the change in y divided by the change in x. The formula in the book looks like this. It's y2 minus y1 divided by x2 minus x1. So that's the official formula for it. It uses the letter. Can anyone tell me what letter it uses for slope? M is correct. Very good. So the official formula for this is that m is equal to y2 minus y1, x2 minus x1. But what that really means, what I'm really describing there, is the change in x and the change in y. And that's what I've drawn with my arrows here. So the short way of remembering the slope is sometimes the rise over the run. So be careful using this. This is kind of a little shorthand rather than an official formula, but it's one that I like using. So the run is going along this way, and the rise is how much it rises up. Now do use the signs in these. So the one I've drawn here, it rises up 3 as it runs out 10. So the slope of this would be 3 over 10 in the one that I've drawn here. Okay, so that's what I'd like you to know about slope. There is an official formula, but it's really about the change in x, y divided by the change in x. And if you draw this triangle that looks like this, I like to refer to these as the slope triangle. So if you draw one of these slope triangles, a little bit like we did for in the distance, I think it helps us work it out. So here's a question. It says A is 3, -1, B is 5, 2, and we're asked to find the slope of the line. So what I would expect you to do with this first would be maybe just that you draw an x and a y axis. So it's going from 3 to 5. I'm going to draw this a little bit, see what it looks like. So I'm going to draw an axis here, and -1 to 2. It doesn't go up very high. Okay, so I'm drawing an x and a y axis. And look a diagram of the 2 points. So A is the point 3, -1. So that's point A. B is the point 5, 2. This is the point B. And we want the slope of the line that goes through those. So this is 2 points on a line that goes on forever like this. Okay. So there's my line that we're talking about. So to get the slope of this line, I'm going to use the points that it gave us here. So I'm going to look at this little triangle here. Now, would you be able to look at that for me? And just by looking at it, could someone call out for me, what's the answer for the slope here? Or if to break it down, what's the changes that are taking place in this? What would I be writing at the sides of this triangle?
3 over 2.
That is the right answer to the whole question. So here I say, as x increases by 2, y increases by 3. So the slope of the line, which is the rise over the run, is 3 over 2. The y change over, I don't want to use that pen. Okay, so there's the line. If I was asked to draw a perpendicular line to that, so you might take out maybe your set square and draw it. But could I do it without a set square? So to do this, I might pick some nice looking points on the line. So the way I've drawn, if I pick these 2 points, for instance, and I'm interested in the slope of this line. So the slope of this line, again, just taking out and drawing a little slope triangle, I could see, or could anyone look at this and even just looking at it tell me, what kind of slope it is? Is it positive or negative?
Positive.
Very good. Because as x is increasing, y is also increasing. And we start to recognize after a while that lines going up in this direction, they're positive slopes. It seems to be when I increase 3 here, I increase 1 there. So the slope of this line is equal to 1 over 3. Now, what would a perpendicular slope to this look like? So again, if you had a set square, you might, when does it look perpendicular? Is it something like that maybe? Is that perpendicular? What do you think? It's a line like this, and obviously there's loads of perpendicular lines. What would it look like?
Yeah.
Something like that? Okay. Now, you could cheat with a set square, but How does it connect to this 1 over 3? It might be hard enough to imagine how to rotate it. Take the triangle and rotate it 90 degrees this way. What would it look like? Well, this line here, would you agree? I'm going to rotate it around this other point, sorry. I'm going to rotate it around this point here. Could you imagine if I rotate that triangle, what would it look like? This line would rotate around to look like that, wouldn't it? Could you imagine that? So this line goes up. So if I was to do that triangle, you could imagine how the line that's length of 3 would rotate up to here. What would happen to the line of 1? What would the triangle look like? Could you imagine the triangle might look like this? Okay.
Yeah.
Now, this is a really important idea. Now, if I do that, by doing this, I can actually see the perpendicular line. You see this line here that I've drawn? Now, I'm going to maybe give it a red color. That line is perpendicular to the red line, now, to the black line. Can you see it? Does it look perpendicular?
Yes.
Now, this is a really, really important idea. So this line here is the perpendicular line to the given line. Now, the question, though, is, what's the slope of this new line? This is the perpendicular line. What slope does it have?
Negative.
Very good. Firstly, it's important to recognize this has a negative slope or this has a positive slope. What's its value? Now let's see what happens. We could go out this way, increase x by 1, and what happens to y to get from this point down to this point?
Negatives by 3.
It goes down by 3. So this perpendicular slope, the symbol for perpendicular is this upside down line here. This kind of like an upside down T. Would be the rise, which is a negative rise. It actually falls. Negative 3 over 1. Okay. Now, can anyone see a relationship between these two numbers? So this has 1/3 and the other one is negative 3 over 1. Can anyone tell me, is there a relationship between these two numbers?
They both have the same numbers on them.
Yeah.
Split.
Do after switching up, anything else after happening?
There's a negative.
There's a negative sign. So there's this relationship. There's a word to describe how these change from here. They're called negative reciprocals. Now, that's a fancy term to say, turn it upside down and change the sign. A slope, and I'm telling you about this slope, a slope is maybe a half. Could you tell me what the perpendicular slope to that is?
-1. Negative 2 over 1.
Negative 2 over 1, which is correct, which is just negative 2. Perfect. Let's try another one. I have negative 3/4, and sometimes it's written like this. What's the perpendicular slope to negative 3/4?
4 over 3.
Perfect. Positive 4 over 3. Brilliant. I'm going to try one more. I have a slope of 2, and I want to know what the perpendicular slope to that is.
-1 over 2.
Negative 1 over 2 is correct, because I imagine that 2 is 2 over 1. So negative 1 over 2 is correct. Just to say something else about these two numbers, if you have a calculator in front of you, would you take any set of these numbers? So these are perpendicular slopes. Would you multiply any pair of those numbers and tell me what you get? So for instance, if I have a half and I multiply it by negative 2 over 1, what's the answer?
-1.
Negative 1. And this is the rule. Perpendicular slopes, when I multiply it, if I multiply m by m perpendicular, the answer is always -1.